Hi.
Hey, so they give access to Geeks for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Hi, and welcome to Geeks for Geeks. Today, we would be doing the post contest analysis of GFG Weekly Coding Contest. So, basically, I can say that this contest, after a lot of requests, like to be honest, I went on to the problem setters, explained them the problem. I tested the problem myself before the contest. And to be honest, this problem as of now went fine for all of the three. Like no test cases were wrong, no problem statements were absolutely very tricky, and it was awesome, to be honest, in my point of view. So so what was the feedback from your side? Let's hear the feedback from your side. Quickly tell me how many problems you were able to solve, any feedback that you want to be processed from the next interview series. Okay, satisfies the condition, so it's nice and sub-array. Okay, fair enough. All the problems, he was able to solve all the problems in 30 minutes. Okay, it was nice. Okay, fair enough. Anyone else who would like to give us feedback? I would be waiting for the next 30 seconds, I suppose, and then we'll be moving forward to explanation of the test cases. Oh, the problem itself, I tried but was not able to solve. Okay, that's absolutely on your end. Any issues with the contest itself? Okay, so I think we can move forward. We are pretty good. So entire screen, let me turn on the DND thing, and we are good to go. So let's start with the very first problem of this. So in the very first problem, I would just find it. Okay, this is the very first problem. Okay, so you are given, so have I added it to the string? Let me just see. Yep. Okay, so in this one, you are given an array of n integers. An array is said to be nice for index 1 if array arri is equals to I. So it just means that suppose the given one is 1, 2, 3, then the indexing, one based indexing, it is told here. Consider one based indexing. The indexes would be 1, 2, and 3 itself. So for this subarray is a, I can say, a good subarray. This is what is told, a nice subarray. Why? Because for 1 to 3, the output is 3. That is why the output to this is 3. Now here, we don't have any elements where we can say it is nice. That is why the answer to the nice subarray length is 0 itself. Like there exist no subarrays. Okay. And this is also nice. Okay, this one 1 2 is also nice. Okay, so basically we need to find the length of the longest sequence in between which have continue 1 2 3 4 5 itself. Okay, so it might be concealed in between 9 8. So let's just take 1 2 3, and here it can have, let's say, 5 8 then 9. So what we can do is we can simply have a counter with 1. Why? Because whenever we see a 1, we need to start considering what is the length. Okay, so no one up till this point, no one up till this point. Here we see a 1. So we would start a counter with what? 1. And this 1 would become 2. Now we would try to find 2 from the next element. We found a 2. So we would update the counter. We would update this counter. Then we start finding 3. We found it. Update the counter. Update the counter to 4. But here we are not able to find, and the next element is not equal to the element that is desired. Whenever we find an element which is not equal to the desired thing, we would say C is equals to 0, and counter this desired element would become 1 again. So whenever we see an element equal to the desired element, we increase the value of C and we increase the value of the desired element. But and we keep doing it and we keep storing it in a global maximum, but we don't see it, then we just reset the counter to 0 and have the counter D is equals to 1. This is simple. So now we would start the coding part. Okay, so I think this is the nice subarray thing. So am I clear with the problem statement? So output is equals to 3. Your output is equals to 3 expected. Please explain the test case. Okay. Okay. So see, here in this we have 1 2 3. That is why the expected output is 3, and your output is also 3. So I don't know why you are getting the error. I think you are printing something else also. Okay, so now can you please tell GFG to enable pressing enter where it says? So can you please tell GFG to enable pressing enter on the editor where it says driver code ends? Okay, I would do it. In the first question, one test case was failing in submission, but the correct answer. Please explain it once more. Okay. Okay. So see, we can have a nice subarray, concealed it between a random subarray. Okay. So let's say the nice subarray is 1, 2, 3, 4, and it is concealed between. Suppose this is again 1, 3, and concealed between 4, 5. So we first say that the desired element we want to have is 1, and the counter is equals to 0, and the answer is equals to 0 up till now. We come to the very first element. It is equal to the desired element. So it would become 2 and C would become 1. And as C is greater than answer, so we would update the answer. Then we come across the next element. It is not equal to the desired element. So we would again make it 1 and C becomes 0. Okay. So see, if you consider this as the whole array, if you don't consider this, then you can see that the answer for this array is 1 itself. Okay, fair enough. Next we come across again 1. It is equal to the desired element. So this would become 2 and answer would become 1. Then we come across 2. It is equal to the desired element. So it would become 3. Okay. And this would become 2. Okay. As 2 is greater than the answer, so we would update it. Then we come across again a value 3, which is equal to the desired element. So we would make the desired element equal to 4 and C is equals to 3. 3 is greater than the answer, so we would update the global answer. Next, we come across 4, okay, which is equal to the desired element. So we would make this as 5. C would become 4, and 4 is greater than 3, so this would update. Next, we again come to the next element, which is equal to 4. But the desired element we wanted is 5. So again, we reset everything. D would reset to 1, and 4 would C would reset to 0. 0 is not greater than 4, we won't update it. Then we again move forward. Is it not equal to the desired element? We would again reset the counter to 1, and C is equals to 0. After all this, we have found the answer as 4. This is how we would move forward. So am I clear? Engineering blasters, give me a quick one if this thing is clear. You start pointing from where you see. Okay. सर बहुत लेट हो रहा, प्लीज जल्दी शुरू कीजिए. Okay. So it's so I have already started, I think so. No, we need to find the subarray. The subarray should have that condition. The array shouldn't have the condition. It has never told me that the array should have the condition. We need to find a subarray which has this condition. Okay. Now let's move forward to the coding part. So problem statement is different and you are explaining different things. Okay, let's see. The problem statement is saying that an array is nice for this, and your task is to find the length of the longest subarray of the array which is nice. So you need to find a part of the array or the whole array. So you can say, so I think you don't know this, but if you have an array of 1, 2, 3, 4, then whole array is also a subarray. A single element is also a subarray. 1, 2, 3 is also a subarray. Okay. So whole array is also considered as a subarray itself. Okay. Now am I clear? Just give me a quick one. Now I would say that the global maximum value is equals to 0. And we would start the counter is equals to 0. And we would say the value, desired element value is equals to 1. Now we would start the iteration. For int I is equals to 0, I is less than n and I plus plus, and we would say if the current element is equal to the desired element, then desired element would increase and the value of C would also increase. Okay. Else and here I would say mx is equals to max of mx comma C. And else simply counter would become 0 and the desired element would again reset to 1. At the end, we would simply return the answer. Let me just see if there are any compilation errors. So this is equal to 1. Okay. Okay. So we got the correct output. Now I would be simply stop sharing the screen, present my tab itself, and you tell me the point at which you were not able to understand. Sir, ARRI is that's I got. That's I got. Let's move to the code part, sir. I've already moved forward. यार अच्छा नहीं लगता, यार यही नहीं अच्छा लगता. What? Satya. Explanation clear now. What you don't. So tell me what you don't like. Statement is controversial. Can you explain what does it mean for another understood? That for nice whereas I can understand it, then ARI is equals to 1. Nice array, so I can understand it is written that ARRI is equals to 1. Yes, it is equals to 1, but when you see the sample test cases also, suppose even if you don't know what the single whole array is also considered as a sub array, even if you don't know, but if you see the sample test case, you would understand that it's very easy to know that a part of the array is also considered in the answer. Second question took a lot of time. Okay, I would move forward to the second question. So I think I'm clear. Give me a quick one if this thing is clear. Then I would move forward to the next question. Give me a quick one if this thing is clear. Any issues on the first question itself? Here the index should start from 1. The index of the sub-array should start from 1. Okay. So would move forward to the next question. So now if you see this problem, this problem is a very good problem. Okay. So now see. This problem was absolute beauty, to be honest. Like I too got a wrong answer for a single summation. Okay. So now see. A geek is selling. He distributed all the flowers. So I think you have already read the problem. So I would tell you the problem. So suppose see, it is told that 1 represent that there is a lid present and 0 present that it is open. So it is told that there are some flowers, okay, which have a value associated with it. Let's say the flowers have the value 1, 10, and 2 itself. Okay. 2, 10, and 1. Okay. And they have some values associated. This is 2, 10, and 1. This is index 0. This is index 1. This is index 2. And if there is 1 present, that means there is a lid. So now it is told that you can transfer a lid. Like suppose this is a bottle that has a lid. So I can take up this lid and I can keep it at this point. But I can't keep it here and here. I can just keep it before this point. So a lid, if it is present, if it is present on the ith index, can only be kept on I minus 1th index. Nothing more, nothing less. So if I have taken a lid from I to I minus 1, this doesn't mean that in the next iteration I can go to I minus 2. It just means that I can just move it once. Okay, I can just move it once. I can just take up a lid and keep it here. I can't keep it here. I can just take up a lid, keep it here. This is what is told. Okay, and you need to find the largest value that is getting up from the lid closed. Translating the same in Hindi would be that सारे वैल्यूज पे सारे बोतल, लेट्स से सपोज वी हैव अ लॉट ऑफ बॉटल, हमारे पास बहुत सारे बॉटल है, किसी के ऊपर लिड है, किसी के ऊपर लिड नहीं है. अब हमें ये बताया गया है कि ये लिड निकाल के इस बॉटल पे रख सकते हैं, इस बॉटल पे, पिछले वाले बॉटल पे, नाइदर दिस नाइदर दिस. अगर हम लोग इस बॉटल पे लिड रखते हैं, लेट्स से द कैपेसिटी ऑफ दिस वाटर बॉटल इज 2 लीटर्स. सो अगर इस बॉटल पे हम लोग लिड रखते हैं तो हमें 2 लीटर्स का रिवॉर्ड मिलेगा. जिसके ऊपर लिड रखा रहेगा वो हमारा रिवॉर्ड होगा. सो हमें मेन एम हमारा यही रहेगा, जिसमें ज्यादा वैल्यू है उस पे लिड लगा रहे, so that we would get a large output. This is what is the question itself. Let me explain you the test cases too. So moving forward to the test cases, we are told that we have 3, 5, 2, 9, and 1. And the lid we have is just 1 and 1. So see, this lid can move to this lid, but this already has a lid. So I can say this can move to this one, because from 2 I can transfer to 5 because it is greater. Suppose यहाँ पे 2 liter है. Suppose this is 1 liter and I also have a bottle of 2 liters. So I should save that 2 liter because it is greater than 1 liter. So I should keep a cap on that. So if the cap is associated with a value of 2, if a cap is associated with a value of 2, I should transfer the cap to here and I should make this 0. So 9 plus 5 is equals to 14. That is how the output is there. This doesn't mean that if I had a 10 here, I can move forward this lead to this. I can't do that. Why? Because एक ही point move कर सकते हैं and we don't repeat it. Am I clear with the problem statement? Give me a quick one. Just give me a quick one if a problem statement is clear. Question 2 can be solved using DP, okay? But I have a straightforward solution to be honest. Only can transfer the lid to a non-lid left basket if there exists one. No. Like जिसमें lid लगा हुआ है उस पे फिर से भी lid लगा सकते हैं. It doesn't mean that 2 बार lid लगाने से 2 का value मिल जाएगा. इस lid के ऊपर और एक lid भी लगा दो, this would be saved. Okay, this would be saved. Okay, so now when I saw the problem, let me tell you how I thought about this problem. So when yes, the stream would be saved. So when I saw this problem, I thought that if a lid is kind of like this, suppose we have 3 and we have 2, and there is a lid present at this, there is not a lid present at this. So what I should do is, so if the before value has a non-lid and it is greater, अगर ये बॉटल है, ये 1 लीटर का है और एक बॉटल है जो 2 लीटर का है, so 2 liter is more beneficial to us than 1 liter. So I should open up this cap and I should put it on a second 2 liter bottle. So what I should do is, I should take up this lid. If the before one is a non-lid, I should keep it here. And this would give me a AC. I thought about this and then I coded this, but I got a wrong answer. Why? Because of this test case. See, in this test case, this is the tricky test case. In this test case, for 1, we already have a lid at 10. So we don't need to do anything. 1 is already saved and 1 is saved. Now we come across this one and we say that 2 is not better than 10. So let's save this one only. So the answer to this, by using the idea by us, would be 11 only. Why? Because for this, the before one already has a lid. For this, the before one does not have a lid, but it is less. So अगर हमारे पास already 5 liters का bottle है जिसमें lid लगा हुआ है और पिछला वाला सिर्फ 1 liter का है, so we should keep that lid with 5 liters only. This is true, but see, what we can do is, if we transfer this lid to here and this lid to here, then the value would come out to be 10 plus 2, that is 12. So the maximum value of this is not 11 but 12. So this greedy approach fails at this point. Am I clear till this point? Give me a quick one. Like this approach would fail. So Q1, can we solve bubble sort by finding the nth max? Can we solve using bubble sort? No, we can't do it using bubble sort because the number of elements are 10 to the power 5 and the time complexity of bubble sort is n square. So 10 to the power multiplied by 10 to the power 5 base is the same. So the powers would get added. So 10 to the power 10, which is greater than 10 to the power 8. So that is why we would get a time limit exceeded. Yes, we can perform this operation only once. See, for here also, for this lid, I have performed this operation once, I have moved it to this. For this lid, I have performed this operation for once and I have moved it to this. So for one lid, we can perform only one operation and we are doing it. We are not performing 2 operations. So this is also correct. So this is correct, but using the idea we are getting this value. So am I correct? Give me a quick one. Poke boy, am I clear? Like we are performing the operation only once. Like ये lid यहाँ पे आ गया, ये lid यहाँ पे आ गया. So for one lid it is moving before once only. Am I clear, poke boy? Do I make sense? Okay, I make sense. Thank you. So now I need to do something else. Okay, I need to think of something else. Okay, so now I saw a scenario over there. The scenario was, suppose I had 8, 9, 7, 7, and let's say 1. So let's not take this much value. Suppose we have 5, 4, 3, 2, 1. Okay, and 3 to 1. And so let's say 3. And here we have 2 and 1. Suppose there is a lid present at 5, 4, 3. Suppose the lid is present at 5, 4, 3. Okay. So let's say that this is equal to 1. Let's take this value as 1. Okay. So the answer would be that we should keep a lid over this point. How? Because this lid should move here, this lid should move here, and this lid should move here. Okay. This is correct. Okay. I should be doing this. There is one more test case. Let us take up this. So the answer for this test case is 2 plus 5 plus 4. Every lid should move one position. Now let's say that we have 1, 2, 5, 4. Same test case. 1, 8, 9. Okay. And we have a lid at this position. 1, 1, 1, 1, 1. And this should be 0. Okay. We can make a lid go by before position just once. So I can take up this one. So I should move forward these all lid to all this. Okay. I should move up this lid and I should also take up this lid. Like these three lid should move here and 8, 9 should remain the same. Do I make sense? Like here we had the lid at 54189. I moved the 541 lid one step forward and I left the lid as intact as 89. Do I make sense? So the answer to the first one would be this. The answer to the second one would be this. Do I make sense? Give me a quick one. Like this figure is making sense to you. Give me a quick one. This makes sense. So if you get out this test case, then the problem is solved. Okay. So by the way, people were asking me about the, okay, you can go for code. Can't wait. Okay. So see this. Okay. So what we can do is, see, we saw that this is moving up, but when we saw this test case, this just means that we need to remove the minimum. We remove the minimum. We remove this minimum and add the first 0. We add the first 0. Okay. If it is greater. And here we would start the iteration from the back. So we would start from the back itself. So we would start the iteration from the back. Okay, so we would add this up value. So we would say 8 plus 9. So we would say the output to this is 8 plus 9. So we would start from the back. So this has a lid, we would add it. This has a lid, 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 add it. Now, when we found a non-lid thing, first, we would remove the lid from the minimum element, like we would subtract the minimum and we would add the new value. And this is done. Okay, so I can solve up this problem like this. But if there is zero पहला question गलत है यार ये बेवकूफ. Okay, but if there is s is equals to 0 1 1 0 1 1, 0 1 1, suppose this value is there. If we have this value, then see, we have 9 8. Okay, we have 9 plus 8, then we saw 0 value. So here we would first check 9 plus 8 is equals to 17. So 17 minus the minimum of both, that is 8. So 17 minus 8 is equals to 9, and then we add 1. So is 10 greater than 17? If it is not greater than 17, we would keep it as it is. Here, removing the minimum element is not providing us any good. So we would keep a global maximum also. If the new value is also equal to min, then remove and then add again. Like the answer would still be the same. Okay, so we would initialize a flag which would tell us if we have found a value as 1 or not. Okay, then we would initialize the answer is equals to 0, and then sum, where we would store the sum, that we got a 17 value now. Remember, we got a 17 value, so we would store this sum at this point. Sum is equals to 0, and then we need to store the minimum element. So min, so mn, just mn, minimum element, and we would, to find the minimum element, we initialize with a maximum element. So we would say int max. Okay, now we would start the iteration from the back. For int I is equals to 0, I is greater than equal to 0, and I minus minus 1, I minus. So if we see s of I is equals to a lid, if it is equals to a lid, first we add the temporary sum in a sum variable, because we need to see na 17 is greater or 10 is greater, we need to see that. So we would first add that sum. We won't directly add it to the answer, we would add the sum to a of I. Okay, we would add the sum, then we would say find the minimum. So mn is equals to minimum of mn comma a of I. Okay, and we would say that yes, I saw 1, so I would say flag is equals to 1. If we see a 0, what should we do? Okay, so if we see a 0, first we would see if earlier we have seen any 1 or not, because suppose if the value is 0 0, then I can't add that value by any means. So I need to clarify that I have already seen a 1 or not. So if I have already seen a 1, that is flag is equals to 1, that I have already seen a 1, then I would come here, add the value to the sum, and then subtract the minimum value. Mn is equals to minimum of mn comma a of I, and then answer plus is equals to the sum we have all got and remove the minimum. Okay, like consider the first element also as minimum. Someone was telling me, na, see, suppose this one, so 1 1, and here we have 0. Or suppose this is 2, 3 and this is 1. So now the minimum element at this point is equals to 1 and the sum is equals to 1 plus 2 plus 3, that is 6. So we would remove 6 minus 1. Okay, so the output is still 5. So we are not doing any iteration. Okay, sum minus the minimum element. We would add it. Okay, now we would make everything like we have used this one. So we would say flag again becomes 0, then mn is again equal to int max. Okay, and sum becomes 0 again. Okay, after all this, suppose we see suppose we see 1 1. Okay, then it would be stored in only what, the sum variable only, it won't be added to the answer. So if we have the flag till the end also, so flag is till the end, then answer plus equals to the sum that we have got, and then we would return the answer. Now tell me the line number at which you are not able to understand. Okay, tell me the line number at which you are not able to understand. Till then, I'm just clearing out the board. So first, zero values has to be greater than min to perform that operation. Explain the test case. Which test case? Give me a test case to explain. Quickly give me a test case to explain, and I would explain that test case only. No worries. I'm ready to do my effort. On your end, just simply like the video, comment the video, and it's done. The last part is not clear, the flag part. Okay. So let's say, so the last part was this. Yes, flag one. Okay. So let's say the given value is 1, like the given value is 1, 2, and 3. 1, 2, and 4. Let's say 1, 2, and 4. And everyone has a lid associated with it. So if everyone has a lid associated with it, then we would add that value to the sum. We would take out the minimum. Again 1, so add that value to the sum, take out the minimum. So sum at the end would become 1 plus 2, that is 3, 3 plus 4 is equals to 7. We have this. But sum is equals to 7, but we want the answer in the answer variable. We want this. So we would say that if if there is some remaining sum, so I can say if sum is remaining, if there is sum is greater than 0, this can be also this value. If sum is remaining at the end, if sum is remaining at the end, then we need to add it. Now see, this would also solve the purpose. This would also give you an AC. See? So now tell me any other part. Line number 54. Yes, explained. Anything more? Am I clear? Shubham Haldar, Satya, and Utkarsh. Am I clear? Line number 47. Let me see line number 47. Answer is equals to sum minus min. What is this one? Okay. Stop the screen sharing. Share the screen itself. Okay. So line number 47, he has not provided a test case, so I would have a test case of my own. So let's say the value is 0, 1, 1, and this value is 4, 5, and 1. Okay, so we would come here and we would say sum plus, so sum becomes equal to 5 and flag becomes 1. Then we come here, it is again equal to 1. So we would simply add it. So 5 plus 4. And the minimum value is 4. Because we are calculating the minimum at this point. Then we come across 0. Here flag is equals to 1 because we have seen a 1. Now sum plus a of I, that is 1. So we would simply add 1. Now minimum is equals to again the current value, so minimum would now become 1. So now at this point we are adding sum is equals to 5 plus 4 plus 1, and then we are subtracting out the minimum. So minimum gets subtracted even if it is from 0, even if it is from 1. Minimum 1 would get subtracted from here. So now do I make sense? So I would remove this one. So why not iterating from 0? So Satya, I need to explain this test case. Let me explain this test case. I would cater each and every doubt today, and let me see how many comments I get. For all the people I'm catering the doubts, I need a comment from you after the video. So see, this is equal to 1 1 1 0, and this is equal to 0 0. So see, the answer is equals to 2. So sum is equals to 2 and the minimum value is equals to 2. And here we would store the global answer. Okay. Again we saw a 5. Again we saw a 5. So minimum would remain the same. Sum would be 2 plus 5, that is equal to 2 plus 5. Okay. It's done. Then we come across 1. We would add that value here. And the minimum would become 1. And then I would say that 2 plus 5 plus 1 minus the minimum value, which is equals to 1. So we would say remove this minimum and add this 7. Okay. We would again come to this 1. Now the sum is becoming 0 after adding it to the answer, and minimum becomes a large value. So sum would become 3 and minimum would become 3. Then we come across 2. We add this value first and then we update the minimum. After doing this, sum minus minimum. So we would subtract minimum also. This both get cancelled. We would add 3. So 7 plus 3, the answer is equals to 10. Am I clear to you, Satya Anand? Why not iterating? Why not iterating from 0? Because if we iterate from 0, we like every lid can come before. So if there was a condition that I can take up a lid from I and I can keep it to I plus 1, then I would have iterated from front. But we are already told that I can reverse the position of a lid. That is why I am iterating from the back. Like एक lid यहाँ से उठा के यहीं आएगा. So better है यहीं से iterate करें. अगर एक lid यहाँ से उठा के यहाँ आता तो हम लोग इस तरफ से iterate करते. So now any confusion to this question, give me a quick 0 or 1. If this question is clear, give me a 1. If this question is not clear, give me a 1. If this question is not clear, give me a 0. Else if it is clear, give me a 1. Okay, so I think I can move forward to the last question. Okay, I'm not receiving any 0 for the last 30 seconds. But nice approach. But how to the observation regarding the question? Like first, I did a wrong step, and I found out that this approach won't work for a like. I thought of an approach that I would take the greater value, and then I found out a test case that this one would fail at this test case, which was step number 2. Then I found out a way to combat that. Like I wrote 2 test cases, and in both the test cases, I found out that I need to remove the minimum from that. Sure, Anshul. So Manpreet, can you quickly tell me the point at which you are not able to understand? Can't we move to I plus 1? No, we can't move to I plus 1. We can only move to I minus 1. And this is the only allowed operation. So I think we should move forward. Now, before moving in this problem, let me tell you that the prerequisite of this problem is multi-source BFS. Multi-source BFS. So let me first explain you the concept of a multi-source BFS. Okay, so BFS, the traditional BFS, tells us that from one point I can calculate the minimum distance to all the other point. But and the algorithm to do that is that we insert the source with distance is equals to 0. We insert the source is equals to distance is equals to 0, and then we perform the DFS, traditional DFS. But if we are given multiple source, like let's say that like there is a colony like of structure, like suppose there is a colony and there is me, this house is of me, and let's say this is of Anshul's house, this is Anshul's house, that is A. Okay, this is Mankit's house, that is M, and this is Satya, so Nitin's house, so this is Nitin's house. And here we have set of police stations. So this is a police station, this is a police station, this is also a police station, and the paths are like this. Okay, so now see, I suppose I want to know the distance of each of the house to the nearest police station. Distance of each of the house to the nearest police station. Like I don't care which police station is there. So in this type of question, I need to use multi-source BFS. Like these all from all this point, I need to start a DFS. So to do that, multi-source BFS is not altogether a different algorithm. The idea is only different. Instead of inserting the source, I would say insert all the source. I would simply insert all the source with distance is equals to 0, and then I would start the DFS and I would say that this is it, and this one would solve. So instead of inserting just one source, insert all the sources beforehand only with distance is equals to 0, and you would be able to do multi-source BFS. Am I clear till this point? Solution once again, share please. So I would attach the solution. After this, I would attach the solution in the description itself. Okay, don't worry. How is that one test case fitting into this? If that box has no lid. So let me explain you this also. Varun, I deserve like I deserve explicit comment from your side after this. Okay, so let me tell you how this is. So I can say that suppose this one has lid. Okay, so this one has a lid and this one doesn't have a lid, let's say. So what I can do is I can first transfer this one to this one. So now after this, the whole array becomes this 1 0 1 1, and now I can transfer this lid. After this becomes 1 0 1. I can transfer this lid now, so 1 1 1 0. So if you see, I'm transferring this lid to a non-lid. I'm transferring this I'm transferring this lid to a non-lid. So I can do that. Do I make sense to you, Varun? Okay, so this is clear. Now let me explain you the test cases. So now see, we have the array like this: 0 0 0 and then 1 0 0 0 0 0 0 0 0 and then we have 1 0 0 0. So a fire would start from this point and a fire would start at this point. Okay, x is equals to 2xy. So 0 1 2. So from this point, that is 2 cross 2, 2 cross 2, I want to reach here. So in the first, in the first second, the fire would reach here, the fire would reach here, because the fire can only move in left, right, up and down. So in the same way, this fire would reach here, this fire would reach here. Okay. So what I would do is, I would go from this point to this point because this part has still not caught a fire. Okay. In the next, what I would do is, the fire would spread from here to here. Like this fire would spread this one. Okay. This fire would spread this one and this one. But we have already moved forward to this one. So we can reach the end without us catching the fire. That is why the output to this is 1. Okay. Do I make sense? Like, is there any more test case? You can't reach safely at 1. Let me explain you this test case also. Mm-hmm. 0 0 1 1 0 0 and this is equals to 1 0 1. So x is equals to 0 0. So we need to start from here. So in the first second only, if I move here, that is the only available option. From this fire, I would get burned out. I would get burned out. Like, this is my position and this fire has this position. So I would get burned out. That is why I can't reach the destination. So there is only one path that I can reach, or I can say that there is two paths, but I need to go this. So if I reach here, this is scorching the fire before I am coming here. That is why the output to this is equals to 0. Do I make sense? Give me a quick one if this test case is making sense. Give me a quick one. So give me a quick one if this test case is clear. Hi Yash, how are you? So the idea is that from each fire, I would do a multi-source PFS. Like, this is very easily understood. Like, see, I would first calculate each of the points time. Like, this one would catch the fire at 5 seconds, this one would catch the fire at 4 seconds, this one would catch the fire at 3 seconds. First I would calculate all of this so I would do a multi-source from each fire and store the minimum time required to catch fire that cell and store the minimum. First I would do that. Then what I would do is, I would again do a BFS from source, and I would only move forward if the new time is less than this time, than fire catching. Like say, translating the same in Hindi, translating the same, like let me first tell you in English. Suppose I am walking down a path. So if that path catches fire before I come, then I can't walk past that fire path. But if that path catches fire after I walk past it, then I can walk it. Like एक रास्ते में अगर पहले से आग लग जा रही है तो हम लोग उसको पार नहीं कर सकते. अगर बाद में आग लग रही है या आग नहीं भी लग रही है तो वी कैन डू इट. दैट इज वाई हम लोग पहले ये डिसाइड कर लेंगे कौन कौन सेल कितने टाइम पीरियड ऑफ टाइम पे आग लगेगी, और फिर हम लोग सोर्स से मिनिमम पाथ मिनिमम स्टेप निकालेंगे डेस्टिनेशन तक एक बीएफएस करके, और हम लोग उसी टाइम आगे बढ़ेंगे. वो वाला स्टेप तभी लेंगे जब ये नया स्टेप आग नहीं लगा हुआ है, या फिर नया स्टेप सपोज करो हम लोग नया स्टेप 5th सेकंड में पहुंच रहे हैं बट आग यहाँ पे 7th सेकंड में लगेगा. सो वी कैन डू दैट. Okay, so we would first do a multi-source from each fire, and then we would do a BFS from the source. This is the implementation problem after you have successfully known multi-source BFS. Do I make sense to you? Give me a quick one. May I move? So if you want me to move to the coding part, give me a quick one. If you want me to explain anything, kindly mention it. Samriddhi, can you quickly tell me the point at which we are not able to understand? Like the code is absolutely very hefty enough. Good enough. I think we can move forward. So I would start this. So I would move this to this. And what I need to do is I would need to move in all the 4 directions. Okay. So to move in all the 4 directions, I would use a dx and dy array. Dx of size 4. And this one would be 1 comma minus 1 comma 0 comma 0. And this one would be a dy array of size 4. Which one would be 0 comma 0 comma minus 1 comma 1. This one would end. After this, I would say that if, like, suppose I'm at the corner element, so I can't move at this side, I can't move at this side. Why? Because that is out of bounds. So I need to respect the boundary at which I'm standing. So I would code a function to tell me that if I'm on the correct, like if I can visit that or not. So if the current coordinate is xy and the size of the array is nm, then I would say if x is negative or y is negative or x is greater than equal to n or y is greater than equal to m, okay, then I would say return a 0 at this point, else we are good to go. Like all this single conditions are a violation condition. Like index can never be negative, index can never go greater than equal to n, index can never go greater than equal to y. All this is done. Now we would start this part. I'm a very lazy person. I won't be writing ARR again and again, so I would be writing A again. So I come at this point. Then I would first say that fire distance. First we would calculate the fire distance one. So I would say vector of int, and I would say fire distance, and this one would be of size n cross m, vector int, and this one would be m and int max. Like I would initialize it with a very maximum. Like suppose a path is not catching a fire in the end also, so that would have a very large value, so I would know yes, this is not catching a fire. Okay, so now I would need to insert coordinate is of x and y, so I would need to make a queue of pair int comma int. Okay, queue. And now I would say in like a multi-source BFS tells us that I need to insert all the sources. So I need to insert all the fires. So I would iterate over all of the matrix to check all the fires. So int j is equals to 0, j is less than equal to m, and j plus plus. And I would say if the current coordinate is a fire, if a dash I a dash j is a fire, okay, if it is a fire, then push that I cross j and make the distance to catch fire. Let's suppose I am only catching fire. So the time period of me catching a fire is 0. Of course, me dying would be a little bit less, like apart from this. So I cross j is equals to 0 itself. Okay. So I would insert all the fire positions into the queue with a distance of 0. Okay. And then we would start the like traditional BFS. So we would take out the top auto TP is equals to Q dot front element. Then we would say int the current xi is equals to Q dot TP dot first, and yi is equals to TP dot second. Okay, I would do this. After this, I would remove the front element Q dot top. Then I would work in all the four directions. So for int I is equals to 0, I is less than 4, and I plus plus. Okay. And I would say new x is equals to xi, old I plus dx of I. Int ny is equals to yi plus dy of I. Okay. Now if the new position is valid of new x and new y n and m, if it is valid and already stored distance is greater than the new distance, like suppose we found a better distance, so we would update it. So if distance of nx and ny, if it is greater than the new distance, if distance of xi comma yi plus 1, if it is that, then we would assign a new distance. If f of new x and new y is equals to this. So we found a better value. So we would insert that better value. So for n q dot push nx comma ny, we would push that, and this is done. Now we would need a new, like we found out all the points which would catch fire at each point. Then we would find a new. This one would be the new distance to reach. So this one would be f test. Okay. And then we would say that q dot, like we would use the same q that we used above. Okay. Why? Because this while loop would only end when every element is out of the queue. So we already have an empty queue. So we would use that queue only. Why to use a new queue? So int x and y, from where we would start the BFS. Then we would say the distance of x and distance of y is equals to 0. Suppose I started walking from the current position. Suppose I started walking from the current position. So suppose I started walking from this room. So the time required to reach this room is 0. I did this. Then I would simply copy everything from here. Like the same old traditional BFS code, I would copy, and I would only change this one. If this part is valid, if this part is a valid one, if this part is valid, and f of this, like this one is catching fire, this one is catching fire after distance of xi and yi plus 1. If this one is catching fire after the value this, then I would simply insert it. Okay, like suppose this room is catching fire at 8, but I am leaving the room at 7, so this is safe. So if the time of catching fire is greater than my time, then I can simply move forward with that. So xi plus 1, xy ii plus 1. Now at the end, I would simply return. So if I am able to reach the destination, so destination of n minus 1 comma m minus 1, if I'm able to reach the destination, is not equal to the int max. If I'm able to reach not able to reach the destination, if I'm able to reach the destination, I would return 1, else I'm not able to reach the destination. Now let us just compile and run and see how many errors am I making. Okay. Okay. I'm making an error in this big long code. So let me just see the part of the error. So 1 minus 1, 1 minus 1, bool valid x, y, and m is x is lesser than m, y is greater than m, return 0, else we return false. Okay. We start with n cross m. We start with n cross m, and then we assign everything with int max. Then we move forward to all of this. If AI is true, then we push it into the queue and we make it f distance is equals to 0. Now we again have q empty is equals to tp is equals to front q dot pop x plus tx of I, y plus tx of I, ठीक है. Then we have new x and an m, and f dis of nx plus ny is greater than what is already stored. Then we would say f of nx and ny is equals to f dis of xy and xy plus 1 nx and ny. So vector of distance of n cross m, and we would assign it with maximum. Okay. Then we would say distance is equals to 0. Okay. Then we would front it, and then we would keep it to the front. Okay. Nx and ny comma m and y. If f dis of nx and ny is greater than nx and ny distance of xi and yi plus 1, and distance, this one would be distance of xi and y and q dot push. Now let us just submit this and see. If the distance of nx and ny and q dot push. So can anyone find the issues? You are always returning 1. Okay, sorry about that. Okay, so I would share the whole code. Like, this is the point from which you should start. And now I stop the screen sharing. Like, coding the multi-source BFS without using macros is a very long one. So tell me the point at which you are not able to understand. I applied the same fire as the same simple. I have applied simple BFS plus padding fire. It got accepted. Yes, absolutely, no issues. Is there a DFS approach? No, DFS doesn't find the single source shortest path. Like, DFS is not a single source shortest path algorithm, so this can't take part. एक ही तो दिल है भैया, कितने बार लोगे? Okay, so I have applied the simple DFS spreading plus spreading fire. So spreading fire is multi-source only. Okay, what if n and m is having fire and your x is n minus 1 and y minus 1? So if n minus 1 and m minus 1 is having fire, then the distance is 0. So the distance to that of catching that part is 0. So we can't move forward to that part. It should be a true or a false. Yes, 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 yes. I understood your concern. Like I should say, if like this doesn't have a test case, like if a of I, f a of x and y, okay, is not equal to is not equal to the value 1, then only we should insert it. So if you don't insert it, this BFS won't be performed and the distance stored would be int max, so return 0. So yes, this was an edge case which has not been handled in the back end of the test cases. Good enough. Who is this person? Shivam Chaurasiya. You deserve a high five. So anything else you want to ask? So for those people whom I have explicitly explained him or her, I deserve a comment from your side. Most welcome. Okay. So I'm not receiving any doubts for the last 30 seconds. So in the banner, ask me anything. Like for the next 3 minutes, it would be an ask me, like 2 minutes, 45 seconds, it would be an ask me anything session. You can quickly ask me anything, and then we would turn off the session sharp at 9:45. Else, I would just simply like this waiting period. I think I'm good to go. So that was it from my side. If you had any concerns or issues, you can ask them in the comment section. And if you're not able to debug your solution and there is absolutely no one to help and you are helpless, then you can ask me on LinkedIn itself and I would be helping you. So, giving you my LinkedIn ID. So, if you're watching the stream in the recorded version, if you're watching the stream in the recorded version, feel free to like and comment the video so that the reach of this video could be increased. So this here goes my LinkedIn, and I would be attaching the solution for each of the problem. So that was it for today. Thank you and have a nice day. Good night, everyone.